मुझे बताइए जब स्टार्ट होता है। गुड इवनिंग फ्रेंड्स, कैसे हो आप लोग? सब बढ़िया? मैं तो बहुत अच्छा हूँ। तो शुड वी स्टार्ट द क्लास, है ना? तो टुडे वी हैव limited number of topics because एक ही क्लास हो पा रही है. We do not have two classes today, and we would be dealing with parliamentary committees. We'll be dealing with Indian diaspora. Indian diaspora is a major topic that we missed in August, so we'll be dealing with that. But first, we would be starting with the Nobel Prizes. इसमें we will deal with Nobel Prize in Science and Technology में physics and biology or physiology or medicine today. These two things we'll be dealing with today. Okay. In the next class we'll cover chemistry wala Nobel Prize. Other Nobel Prizes we have covered in pre-fact wala section ki who is getting Nobel Prize for peace and all those things. We'll be dealing with pre-fact, but जो science वाले Nobel Prize हैं, those are important even for mains examination. So let us first deal with Nobel Prizes and then we'll come to other topics. In GS3 after Nobel Prize, we have another issue, which is the Unlawful Activities Prevention Act, because recently एक organization ban हुआ है. What is the name of the organization? PFI. So we will talk about that ban, but before that we will discuss in detail about the act, the main provisions of the act, key issues, key concerns related to those acts, because the question would not be about an individual instance. The question would be about the bigger issue of the Unlawful Activities Prevention Act. Okay, but first let's deal with science and technology. Let's deal with first physics. Physics में science and technology, physics में this year Nobel Prize has been given on the work of quantum entanglement. So let us start with understanding of what quantum entanglement is, and then we'll go into what the three scientists did. Because of quantum entanglement, a lot of other things are possible, like quantum computing, quantum cryptography, other forms of quantum communication and all. So we will also deal with those topics. So first we'll cover quantum entanglement. We'll understand what are the contribution of these scientists and what would be the applications of quantum entanglement. These kind of questions are asked in the examination, both in preliminary as well as mains examination. Abhi, not this year, last year, there was a question on 2014 physics Nobel Prize, LED and associated issue. तो quantum computing बहुत ज़्यादा इंपॉर्टेंट है, तो उस पर अगर नोबेल प्राइज मिला है तो दैट बिकम्स हाईली इंपॉर्टेंट. ओके, अच्छा, बिफोर वी गो इनटू क्वांटम एंटेंगलमेंट और अदर प्रॉपर्टीज ऑफ क्वांटम फिजिक्स, प्लीज अंडरस्टैंड दैट व्हेन वी टॉक अबाउट क्वांटम फिजिक्स वी हैव टू डिफरेंशिएट इट फ्रॉम क्लासिकल और न्यूटोनियन फिजिक्स. हम न्यूटन के 3 लॉ पढ़ते हैं, दैट इज नॉट एप्लीकेबल व्हेन इट कम्स टू quantum particles or very small particles, subatomic particles. To explain the properties, to explain the behavior of subatomic particle, quantum physics was developed at the beginning of 20th century. In the first half of 20th century, the idea of quantum physics came into play. Okay, तो किसी दिन quantum physics को भी हम डिटेल में पढ़ेंगे. उसी का एक प्रॉपर्टी होता है quantum entanglement. तो let's first understand what we are trying to say when we are saying quantum, and when we are using the term quantum entanglement. So first, do we understand that this quantum entanglement will be applicable on quantum particles, very small particles? Okay, so let me to explain quantum entanglement, let me take these two coins. Are these two coins quantum particles? No, ये तो पूरा metallic coin है, बड़ा है. These are not subatomic particles. But for next 5 minutes, let's assume that these are subatomic particles, that these are 2 electrons. These are 2 electrons. We want to understand what is entanglement. So for a few minutes, let's assume that these are 2 electrons. Now, when they interact with each other, they get entangled. And once they get entangled, their behavior would also get entangled. For example, they interacted, they got entangled, you separate them. Paras, you keep this coin. Nihil, you keep this coin. Now these two coins are separated, वापस दे देना. ठीक है? Now these two coins are separated. If Snehil is changing the spin of this coin, the spin of that coin would also change instantaneously. This is entanglement. Basically, I'm saying if this particle changes its spin, the spin of this particle would also change. Why is this happening? What is the force which is making this happen? Which is the force which is making this happen? First of all, let's understand the extent of this entanglement. These two particles, when they are like 10 meters away, they are able to show this behavior. But let's say Snehil goes to jail. कौन से जेल में जाओगे स्नेहिल? Snehil goes to तिहाड़ जेल. पारस यहीं पढ़ रहा है. Your name is Paras, no? Okay. Paras यहीं पढ़ रहा है. Even then, these two electrons that they have, these two particles that they have, remain entangled. If the behavior, Snehil जेल में उस पार्टिकल का स्पिन चेंज कर रहा है, उस इलेक्ट्रॉन का स्पिन, the spin of this electron would change because they are entangled. Even at this distance, let's say Snehil goes to Mars. Even then, these two particles remain entangled. Let's say he goes to a different galaxy with this electron, with this quantum particle. They remain entangled. That is, change in spin of the electron here will lead to change in the spin of electron in some other galaxy. This is quantum entanglement. And it would happen instantaneously. थोड़ा spooky behavior है, like, but this is something that happens. Did we understand? Did we all understand what is meant by quantum entanglement? Let's look at its definition. Two particles having interacted, once they have interacted with each other at some stage, यहाँ पे I should have used the term two quantum particles. We're not talking about non-quantum large particles. Two quantum particles having interacted with each other at some stage were found to have got entangled in a way that the behavior of one produced an instantaneous reaction in the other, even if the two were no longer connected in any way and were separated by large distances. We'll understand more things about it, but are we all very clear about what quantum entanglement is? An electron or a photon which have been entangled would behave like this. Okay, now sometimes these two coins may not have interacted with each other, may not have got entangled with each other, but even then they can get entangled. I'll explain you. Let's say I have two other coins. I have two other coins or two other electrons. वो दो electrons entangled है. This electron was in some other galaxy. This electron was in this galaxy. This electron interacts with Paras wala electron, and this electron interacts with other galaxy electron, which has gone to other galaxy. Now, because these two existing electrons were entangled, these two which have never interacted with each other, by interacting with them, they interact, so they also get entangled, and indirectly they get entangled with their fine. चलो इसमें नहीं जाते, जनरली इतने एडवांस, इतने अंदर नहीं घुसते. We just have to understand entanglement. I hope all of you have clarity on what entanglement is. So, when in 20th century, the idea of quantum physics was developed. How electrons behave, how photons behave. So various principles of quantum physics also came into play. Principles like Heisenberg uncertainty principle, right? Which says that you cannot determine all the properties of a particle at one go. Principle like every particle would be a wave as well as a matter. These are some quantum physics के properties. ऐसे ही there was principle of quantum entanglement. There was principle of superposition. We'll understand what superposition is in some times. Okay, but this went against things like Einstein's theory that nothing can travel at speed faster than light. So when this electron is in some other galaxy and this electron is here, some change here is leading to some change in some other galaxy where light may have taken many light years to reach. Light may have taken a long time to reach. It means their interaction is traveling, or something that is making these two things remain connected is traveling at speed more than the speed of light. Is it true? ऐसा लग रहा है हमें, right? So that's why Einstein raised questions on it. Einstein said that quantum theory is incomplete. It's not able to explain everything. There must be some limitations in it. तो वो यहाँ पे हम बोल रहे हैं quantum physics develop हुआ and Albert Einstein, his special theory of relativity prohibited any signal from traveling faster than the speed of light. This seemingly instantaneous communication, इसमें quantum entanglement, instantaneous communication is taking place due to entanglement went against Einstein's theory. Therefore, Einstein proposed that something was missing and quantum theory was incomplete. There must be something else, some local invisible properties which are making them behave in a particular manner, because nothing can travel at speeds more than speed of light. So its change in behavior at faraway places may be because of the local scenario, and quantum physics has not been able to explain everything, or quantum mechanics has not been able to explain everything. He raised this question. But in 1935, he, through a research paper, raised these issues. Einstein raised these issues. But experimentalists who were working on quantum physics, slowly and slowly, they were proving that everything that quantum physics or the theories of quantum physics were saying were also getting experimentally proved. Quantum physics जो बोल रहा था वो सब कुछ सही निकल रहा था. But till that time, experiments to test entanglement were not there. Where do these three scientists come? These three scientists come where they proved that this entanglement is actually taking place without any other local variables playing a role. समझ में आ रहा है? देखो, quantum mechanics or quantum physics is the most difficult areas of area of physics or area of study. So we do not have to get into that difficulty, but broad idea होना चाहिए. It is, and the smartest people on earth, the most intelligent people on earth are working on quantum physics. जो दुनिया में सबसे इंटेलिजेंट लोग होंगे ना, सबसे तेज लोग होंगे, they work on these theories. Okay, so if you are not able to understand the basic वाला चीज, or you may feel something very unintuitive, that's fine. But अभी तक जितना समझाया समझ में आया, तो Einstein and various other scientists raised various issues on quantum theory, but quantum theory through various experiments was proved to be that those concepts, those ideas were correct, but till that time experiments to test entanglement did not appear feasible till that time. But then in 1964, Bell developed what is called Bell's inequality. And it was said that if Bell's inequality is maintained, if in an experiment Bell's inequality is maintained, then Einstein would be right. But if it's violated, then quantum entanglement or the prediction of quantum theory would be right. तो जो अपने 3 साइंटिस्ट हैं जिन्हें नोबेल प्राइज मिला, the 3 scientists who got Nobel Prize, Bell's inequality को वो अपने एक्सपेरिमेंट में लेके आए. They brought this into their experiment. John Clauser, the first guy, what did he do? He was the first person to set up an experiment to test entanglement. And in 1972, his experiments produced results that were clear violation of Bell inequality. Bell's inequality violation means quantum entanglement being correct and Einstein being wrong. तो बहुत डिटेल में नहीं जाना, बट ये तो पता होना चाहिए ना कि what did John Clauser do? John Clauser showed that Bell's inequality was getting violated. That were clear violation of Bell's inequality. But there were some loopholes in his experiment. Some concerns were raised about his experiment. The second guy, Alan Aspect, he is credited with improving the experiment so that loopholes or concerns which were raised in John Clauser's experiments were done away with. So he also did the experiment by removing all the loopholes which were raised, which were there in John Clauser's experiment, and he also showed that results were violating Bell's inequality, meaning quantum theory was correct and entanglement was happening without any local variables, local issues. Fine. Third person who has got Nobel Prize for physics for quantum entanglement actually started using it. He practically started using it for doing what is called teleportation of the quantum state. Basically, what he started doing was, there is one quantum particle here, there is one quantum particle somewhere else, they were entangled, change in things here, change in situation here, change in property here, led to change in property there, let's use it. You want to send an information, to someone who's sitting far away, teleport that quantum through this quantum entanglement. He actually did that. So Anton Zeilinger, meanwhile, had already started using entanglement property to open up new technological possibilities. He demonstrated that it was possible to teleport the quantum state of particles to another location without the particle moving anywhere and without a medium. The contribution of 3 scientists. The contribution cannot be explained in one line, but for UPSC, for your answers, अगर कुछ पूछा जाता है कि what happened in what were their contribution, you need not write more than this line. You will not be able to explain the experiment. You're not doing your BSc, MSc physics. You're not doing PhD in physics. So in one line, you should be able to talk about contribution of each of these scientists. Fine? Did we understand? जाके बोलो उसके बारे में. Okay. Any doubts here? Any concerns? Any doubts here? No. We're coming to that. Balbir, right? Balbir is asking, sir, what is the force which is making it happen? Well, explain entanglement is there. By experiments, we have proved that entanglement happens. But what is the force that is happening? That is there. So, the satisfactory theoretical explanation of phenomena. Which phenomena? Quantum entanglement, however, continue to elude scientists. We know that this is happening. We know that quantum theory predicts this, that it would happen, and it is actually happening. By experiments we have identified that. But why is it happening? What is the force which is making them interact? The best brains on earth have not been able to satisfactorily explain it. ये तुच्चा सा टीचर क्या करेगा? फाइन, आई होप आप सब लोगों को क्वांटम एंटेंगलमेंट समझ में आया है. ठीक है, तो क्वांटम एंटेंगलमेंट, क्वांटम, व्हेन वी टॉक अबाउट एप्लीकेशंस ऑफ क्वांटम एंटेंगलमेंट, वी बेसिकली आर टॉकिंग अबाउट एप्लीकेशन ऑफ क्वांटम मैकेनिक्स. So talk about computing, talk about quantum cryptography, talk about everything, everywhere, atomic clocks. These are all applications of quantum mechanics and thus of quantum entanglement as well. Fine. I gave you 2 other coins, no? They all get entangled. Yes, yes. Her second is a very large time when you go to quantum mechanics. तो बहुत ज़्यादा time change होता रहेगा. Yes, that is there. Fine. ओए, वापस दो मेरे electrons. रख लिए. I hope quantum entanglement सबको समझ में आया. Now we'll talk about quantum computing, one of the applications. Quantum computing, let's discuss it in detail, and other things, other applications we'll briefly discuss. उन्हें detail में कभी और discuss करेंगे. Else this entire 2.5 hour class would go in quantum mechanics and its applications and everything. Let's go to quantum computing now. Okay, what is quantum computing? बहुत basic level पे, when we do not have any understanding, we should be able to say this, कि quantum computers or quantum computing, let's say I'm defining quantum computer. Quantum computer is a computer which has enormously high processing power. इतना बहुत basic level पे, this is what a quantum computer is. It works on principles of quantum physics. Will we be able to say this? I'll clearly explain you how it's working on those principles. But when we have to write a definition for mains examination, will this definition be good enough? Writing 2 lines about it, introducing your answer like this. Mehboob is asking what is the force behind this. I think मैंने बता दिया. एक बार definition फिर से समझाओ ना सर. Quantum entanglement का नहीं, अभी नहीं. Okay, let's come back to quantum computing. Did we understand a definition of quantum computing? But before we go to quantum computing, let's understand how the computation system, how our computers work today, and why is there a limitation on their speed. And then we'll be able to understand why quantum computers would be so fast. Fine. So let's say, what do our computers have? Our computers have transistors, resistors, all these kind of electronic equipments, right? जो हमें computing में help करते हैं. So let's simplify everything. Let's say our computer has only this OR gate. ऐसे हमारे कंप्यूटर में billions and billions of gates होते हैं. But let's to understand how a computer functions, or how a quantum computer is different from computer. Let's say this is our computer, and our real computer has billions of these OR gate, AND gates, and इसको use करके a complicated system is created. When you have to do addition, you have to have multiple of these gates to do additions. When you have to do multiplication and so on. But let's say at very simple level, this is what our computer is. This is our computer. This is an OR gate. OR gate में क्या होगा? If you, I'm saying, this is my computer, a traditional computer, and it is an OR gate. So if you send signal of 0, 0, it will give you what? 0. If you will send signal of 1, 1, it will give you 1. If you will send a signal of 0 and 1, it will give you 1. It will give, if you send a signal of 1, 0, it will give you 1. और है ना? तो 1, 0, कोई भी एक 1 रहेगा तो it will give you 1. Right? Computers have these kind of many of these kind of gates और उसको use करके they do this complex calculations. But we do not want to get into all that. But let's say this was our computer. Now, when I'm saying 0, basically I'm giving negative voltage or 0 voltage, and when I'm saying 1, I'm giving high voltage. Right? वैसे how is 0 and 1 represented on our computer? It's represented like this in the form of voltage. Now for this OR gate to do this calculation, it had to work on 4 different occasions. Why? Because at one time, the state of this one input can be either 0 or 1. So state of this can also be either 0 or 1. So 0, 0 पहले हमने दिया, it calculated it, then we changed its state 0, 1, 1, 0, 1, 1, and then we got results for everything. We were able to make 4 calculations, but all these 4 calculations did not happen at the same time. These 4 calculations did not happen at the same time, right? It happened one by one because the state of the input here can be only 0 or 1. It cannot be 0 or 1 at the one go, right? प्रियम समझ में आ रहा है? पक्का? ऐसे एक्सप्रेशन दे रही है कि सर क्या पढ़ा? I'm trying. देखो, I'll help you understand exactly how quantum computers are superior and way better than the traditional computer. This is how traditional computer is working. This is how traditional computer is working. You may have a 64-bit computer. You may have a 64-bit computer, 32-bit computer. वहां पे input ऐसे 2 bit में नहीं जाएंगे. Input will be of 64-bit. Input would be of 64-bit, but let me make it a 8-bit computer, let's say. So there are 1, 2, 3, 4, 5, 6, 8-bit computer. So at one time, input could be either all 0 और कोई एक 1 हो जाएगा, 2 1 हो जाएंगे, and so on. There are how many possible input? 2 raised to 8. Right? But our system will process it one by one. So if there's a lot of calculation that has to be done, our system will take time because our computer system में जितने भी register हैं, transistor हैं, components हैं, their state, there's a limitation on how quickly they can change their state. Because they have to come to one particular state, 0 or 1, to make some calculation, then they have to change their state to come to the next level and so on. Fine? Got it? The limitation of traditional computers. The faster you're able to change these states, more calculations they will be able to do. You can add a multiple of these registers. So आजकल processors, we do not have one processor, we have multiple processors. Parallel computing भी होता है, parallel processing भी होता है. Supercomputers में supercomputers have large capabilities. But even there, what the problem is, कोई भी register, कोई भी transistor, कोई भी AND gate, OR gate, NOR gate, इसका input can be of only one state, output would be of one state, and it would happen one by one sequence. The calculation would happen one by one sequentially. Fine. Now, this is a problem because of which our computers are not able to have this unlimited processing power. There are millions of transistors and capacitors at the heart of computer, but they can only be in one state at any point. There is a limit as to how quickly these devices can be made to switch their state. So classical computers today have not been able to solve a number of computing problems. Classical computer, that is the computer that we're using, even they have become very advanced, there are some problems which they haven't been able to solve. For example, the problem of optimization. Aapne, like, how is there someone who's from computer science background? You are from computer science background. What's your name? मंजरी. आप भी कंप्यूटर साइंस बैकग्राउंड से हैं. आपका क्या नाम है? अमित. अमित, do you know about NP hard problems? Anyone who knows about NP hard problems? मंजरी? नहीं? Like traveling salesman problem is NP hard problem? नहीं? अच्छा. There are some problems which are it's not possible for computers to solve those problems because they involve lots of calculations. So our current computer systems are not able to solve those problems. Because of this reason, cryptography is successful. Why? Cryptography is successful because it cannot be decoded by the current computer system. Cryptography, आपका encrypted information होता है, your encrypted information travels from one point to another. Hackers are not able to steal that because there are some problems which computers are not able to solve and they are using those problems. एक problem होता है जो computers are current computers are not able to solve is factoring of large numbers. अगर आपको एक बहुत बड़ा नंबर दे दिया गया और पूछा गया find out all its prime factors, our current computers are not in a situation to solve it. Because of this problem, it is because computers are not able to solve this, cryptography में asymmetric key cryptography or public key cryptography which is being used in everywhere around us. हम जितना भी cryptography आजकल यूज हो रहा है, that is public key cryptography. It is possible because this problem is not solvable. If this problem becomes solvable, then आपका information steal करके, आपका information read करके उससे आपका data निकाला जा पाएगा. Cryptography would fail. Current mechanism of encrypting your data would fail. Fine? Am I making sense? So, coming back to, this is a problem which is not solvable by current system. Optimization is a problem which is not solvable by computer system. Optimization is basically जैसे मैं बोल रहा था traveling salesman problem. Traveling salesman problem is this problem. A salesperson is given lots of houses to travel. यहाँ जाना है, यहाँ जाना है, यहाँ जाना है. What is the most optimal path he should take so that he is able to cover everyone in the shortest possible route? So if you have 100 houses, you will definitely be able to do that. You'll be able to find your computers would be, but if you increase the scale, current computers are not able to give you the right solution. That is optimization, it's not able to do. Current computer system, even supercomputers are not able to do. ऐसे ही simulation of molecules in chemistry. What is meant by simulation of molecules? Let's say carbon is burning with reacting with oxygen to form CO2. This is, you do this experiment in lab and you find that it has produced CO2. But what if we wanted to make computer simulators where we did not actually make it react, but a simulation may, if we would have got the information, if you react carbon with oxygen, you will be able to get CO2. Computer simulation, do we understand computer simulation? Something is not actually reacting, but simulation is able to give you the outcome. But for computer simulation of molecules to be made, you will have to create all these scenarios. This electron interacting with this electron interacting with this, and this electron interacting with proton, and so many forces and so many things have to be included in that. It will make system very complex, and our current computer system are not able to solve these problems. So our current computer system has some limitations in their computing ability, because of which there are certain problems which are not solvable right now. Got it? सबको समझ में आया? But quantum computing, what was quantum computer? Quantum computer is a computer which has enormous processing power, way more than the current scenario. Is giving us a mechanism, is giving us a method by which we will be able to, using quantum mechanics, have very large processing power. Now, why? So, to understand why, let's go back to this. When our information was stored in the form of voltages, high voltage 1, low voltage 0, our bits were stored like this, or in the form of magnetic field they are stored. जब आपके कंप्यूटर में इलेक्ट्रिसिटी नहीं जा रहा होता फिर भी हार्ड ड्राइव पे इंफॉर्मेशन स्टोर होता है ना, वो मैग्नेटिक फील्ड में इंफॉर्मेशन इज स्टोर्ड. Bit there is represented like this, high voltage, low voltage, और magnetic field में spin के basis पे. Now come to in quantum computers. We are coming to quantum computers. What is quantum computer? We understand. Definition हमें पता है. In quantum computer, how is one bit stored? यहाँ पे quantum computers में we use quantum particles to store bits, like a photon or an electron. Let's say electron. Let's say we use electron to store a bit. So we say अगर इसका spin up है तो let's say it is 1, अगर इसका spin down है it is 0. तो जैसे the way we had an OR gate in traditional computer. In traditional computer we had an OR gate which was basically our computer बहुत basic level पे. In the same way, here we'll have some mechanism by which processor, what did OR gate do? OR gate give you an output by taking an input. In the same way, in quantum computer, we'll have a quantum processor which will take this quantum bit, will process it and will give you an output. It will not be like the current computers that you have, but it will also have. Now coming back to यहाँ पे पुराना ट्रेडिशनल कंप्यूटर, लेट्स से वी आर टॉकिंग अबाउट और गेट ओनली, और दो इनपुट थे, इट कुड बी 0, इट कुड बी 0 और 1 0 1 1 0 लाइक दिस, बट एट वन टाइम इट इज एट वन स्टेट. कमिंग बैक टू क्वांटम कंप्यूटर, लेट्स से दिस इज अ OR gate of quantum computer, OR gate of quantum computer. Okay, here again if you give two inputs, it will give you a one output. How are you giving input? Electron अगर हम use कर रहे हैं, here this electron would be called, if you are storing your 0 or 1 on this electron, this is called quantum bit. How is bit stored on quantum computers? In the form of quantum bits. Here bit 0 1, these were bits, they were stored in the form of voltage, high voltage, low voltage, they were represented in the form of that or in the form of magnetic field. Here it will be represented on the form, in the form of quantum bits. Now comes the reason why these computers are much faster. An electron up spin है तो let's say it's 0, down spin है तो let's say it's 1, or let me represent it differently. Up spin है तो it is 1, down spin है तो it is 0. और let's say a photon has certain properties, अगर property ऐसा है तो ये 1 है, property ऐसा है तो 0. Now for electron to change its property from up spin to go to down spin, it will require some external force, external source of energy. Suppose it requires Q amount of energy to change from 1 to 0. Suppose it requires Q amount of energy to change from 1 to 0. Okay. To this electron, we are not giving Q amount of energy. Let's say we only give Q by 2 amount of energy. What happens? अब ये किस जोन में रहेगा? किस स्टेट में रहेगा? 1 या 0? No, it will go into what is called superposition. It will go into what is called superposition. अभी हमने entanglement पढ़ा, superposition नहीं पढ़ा ना? That is, there is some probability by which it is in this state. There is some probability by which it is in this state. That is, the same electron is representing 1 with some probability and 0 with some probability. It is superposition. This electron is in both the states with some probability. Let's say it is in state 1 with probability x and it is in state 0 with probability 1 minus. When it goes into superposition, the same bit is representing both 0 and 1 with different probabilities. Same bit is representing 0 and 1 with different probabilities. Now come back to this OR gate of a quantum computer. It doesn't look like this. There is no rule कि ऐसा दिखता है. The OR gate of our traditional computer looks like this. है ना? It should also, actually we should make it like this only. But this is a quantum computer का OR gate. Fine. Quantum computer OR gate है. Electron, electron, upspin would have given you an output of 1. But when electron is in superposition, what is the state of this electron? Is it 1 or 0? It is both 1 and 0 with different probability. So this state is both 1 and 0 with different probability. This state is also both 1 and 0 with different probability. So the input right now, can it represent 0, 0? Yes. Because this is 0 with some probability, this is 0 with some probability. Can it represent 0, 1? Yes, this is 0 with some probability, this is 1 with some probability. So with some probability, it can represent 0, 1 also. Can it represent 1, 0? Yes. Can it represent 1, 1? Yes. So the same input, वहाँ पे the state was either 1 or 0. So एक time पे one thing could be, only one thing could be processed. Here, the state is both 1 and 0, and thus these two bits together have been able to represent all the 4 states at one go. If you had a 3-bit computer, all the 8 states could have been represented. If you had a 3-bit computer. So this bit, this quantum bit represented both 0 and 1 with some probability. It also represented both 0 and 1 with some probability. 0 and 1 with some probability. It also represented both 0 and 1 with some probability. So is this 3-bit number representing 0, 0, 0? Yes, with some probability it can be 0, 0, 0. Is it representing 0, 0, 1? Is it representing 0, 1, 0? Yes. 0, 1, 1. 1, 0, 0. 1, 0, 1. 1, 0, 1, 1, 1. It is representing all the 8 states at one go. So when these 3 bits go into quantum computer, parallelly they are able to process all the 8 numbers. If it was a 4-bit computer, all the 16 number. If it was a 10-bit computer, all the 1024 numbers were processed at one go, which in traditional computer would have happened one by one, one by one, one by one, one by one, one by one. This is the core reason which makes quantum computer का processing power huge. Just imagine bits. If we make it a 128-bit computer, 2 raised to 128 calculations could have been made by your computer. 512-bit computer. Think of how many states could have been processed at one go. Am I making sense? Are we all able to understand? देखो, in exam you will not need this calculation. You will not need to show this. Exam में you would only need that definition and then its features and its application. But it's important to understand. Everyone will keep talking about quantum computer, quantum computer. When you think quantum computer, you should be like, oh, why is it fast? It's fast because probabilistically it is able to represent all the possible numbers at one, all the possible states at one go. It will give output. जो quantum computer का OR gate होता, it would have given an output and it would have represented all the different outputs with different probabilities. Fine? Got it? सबको समझ में आया? How do a quantum computer work? Now let's go back to our notes. Sorry? नहीं, probability half नहीं. I'm not saying probability half. I'm saying probability can be 0.2 or 0.8 also. X and 1 minus x. I'm saying x and 1 minus x. X half है तो हाँ 0 and 1, but I'm not saying कि the quantum bit is representing 1 with half probability and 0 with half probability. This probability can be different also. Okay, let's come back to this. Quantum computers use quantum bit. इस साल preliminary examination में ये आया था. Quantum bit किससे associated is something like this, right? These QU bits can take values of 0 or 1 or any of the infinite superpositions between 0 or 1. When Q bits are in superposition, it has some probability of being in state 0 and some probability of being in state 1. At the same time, it is representing both 0 and 1. Fine? समझ में आई बात? Now, they are usually made up of electrons, photons, or even of nucleus, subatomic particles, quantum particles. Say, in case of electrons, spin up correspond to state 0 and spin down corresponds to state 1. According to quantum law, the particle then enters a superposition of states in which it behaves as if it were in both states simultaneously. Each quantum bit utilized could take a superposition both of 0 and 1. Thus, the number of computations that a quantum computer could undertake is 2 raised to n. If there are n bit computer, 2 raised to n number of calculation can be made by quantum computer at one go. So, where n is the number of quantum bit being used. I hope before reading all this, I have explained you how this is happening. So, a 32-bit computer will be able to make 2 raised to 32 calculation at one go. Fine. Are we all clear about it? Do you understand superposition? Do we have clarity on superposition? Did we understand entanglement? Entanglement तो चलो Nobel Prize ही ले लिया. Superposition क्या है? Entanglement क्या है? Now, quantum supremacy. Let's understand what is quantum supremacy. So see, classical computers are not able to solve some problems. Some problems like optimization wala problem, factoring of large number wala problem, and so on. Quantum computers would be able to solve those problems. But have quantum computers solved those problems yet? If quantum computers had solved those, if someone had developed quantum computer and solved all those problems, then the abhi ka current cryptography and current data security situation would have been destroyed. So till now, quantum computers have not been developed which solve a problem which traditional computer has not been able to solve. But recently, Google said that it has developed a quantum computer called it Sycamore. It's there in your notes, don't worry. It has solved a problem which traditional computer would have taken many 100 years to solve. So when a quantum computer is able to solve a problem in real time which a traditional computer would have taken unrealistic amount of time, we say that we have achieved quantum supremacy. It refers to quantum computer being able to solve a problem that a classical computer cannot. The term was coined by John Preskill in 2012. Google, through its 53-bit QU-bit processor, have recently sequenced millions of numbers, which traditional computer would have taken very long time, and thus Google is saying traditional computer would have taken 10,000 years. Google is saying that their quantum computer has been able to do it in 200 seconds, and thus they have achieved what is called quantum supremacy. Fine. There are some online doubts. What is Bell's inequality? Achha. What is quantum dot carbon dot computing impact? How would quantum computer impact blockchain technology? I'll get into this. I'll explain you all this, how all these things, how would quantum computer explain Bell's impact blockchain and all. But first, let's understand the key terms and the basic concepts before we go into other aspects. Now, if quantum computers are going to be so superior, why are we not developing quantum computers? ऐसा होना चाहिए हर घर में क्वांटम कंप्यूटर लगवा दो. If it's because developing quantum computer is not that easy. There are some core issues, core problems. One is the problem of interference. Think of an electron. On an electron, you are storing information, right? Electron needs very small amount of energy to change its state. So your computer through which that electron will travel by carrying that information 0 or 1, both 0 and 1. Your processor will give it some energy to make some modification and give you some output. But what if some other form of energy? Because that computer will have a lot of other energy from the atmosphere, changes that. Your whole calculation would get hampered, right? So interference, we are talking about that problem. So developers of quantum computers are using various mechanisms to deal with interference. For example, quantum computers which are being developed, they are many of their components are working at extremely low temperature, so that किसी भी तरह का interference नहीं होगा. They're functioning at very, very low temperature. Then another problem is error correction. In spite of everything, these electrons or these photons which are carrying information, which are being processed, they would be affected by some energy, and we have to remove that error from the output. That is a major challenge. And third is output observance. Observing output in a quantum computer is very difficult. Why? Heisenberg uncertainty principle. अगर आप रीड करने की कोशिश करोगे तो मॉडिफाई हो जाए. So let me explain it in this manner. Quantum mechanics says, or Heisenberg uncertainty principle says this, कि you will not be able to determine both location and velocity of a quantum particle at the same time. If you will try to determine its location, its velocity would change, because to determine it, you will supply some, you'll need to interact with it. If you will try to determine its velocity, its location would change. So how is the information on a particle stored? In the form of its property, upspin, downspin. So when you try to read that output, you have changed its property. When you try to read that output, you have changed its property. So reading the output of a quantum computer is also a challenge. That is observance. What was the third problem? Output observance. Observing the output is a challenge. बात समझ में आ रही है सबको? These are the three core problems, and that's why quantum computer is not like a traditional computer कि कहीं भी assemble होके बन गया. Quantum computer, the world's biggest companies are working towards developing quantum computers, and they have yet not developed a commercial quantum computer कि ये लो quantum computer use करो and solve the problems which traditional computers were not able to solve. They haven't been able to do that because of these limitations. Sorry? I know, it prevents hacking. But hacking prevent कर रहा है. I'm sending some information to you. बीच में this person is trying to read that information changes. And thus this person is not able to read this information. That's fine. But when I'm sending that information to you, you will need to read it, no? And when you're reading it, it changes. So observing the output in the same way, when your computer has processed something, you have given it 0, 1 or gate, it should give you 1 as output. But when you're reading 1, it is converting into 0. Because observance, output observance is again a challenge here. Fine, got it? When you read an output, you are reading output, all the possible outputs with different probabilities. Yes, when you gave 0, 1 as input, you're not actually giving 0, 1 as input, you're giving 0, 1 and 0, 1, both the levels with different probabilities. And your output, you'll have 4 outputs with different probabilities. The same electron will be representing, same output will be representing 4 different outputs with different probabilities. Fine, come back to the wait, नहीं जाना है, इतने डिटेल में नहीं जाना है. Come back to this quantum. What are quantum computers? Will we be able to explain that in one line? Will we be able to define that? अगर पूछ लिया why, what is the core reason because of which it is faster, you say that quantum bit are able to represent multiple state which a traditional bit is not able to do. ये बोल सकते हैं, right? ये हम सबको समझ में आया. Then quantum supremacy we understand. Give example of Sycamore of Google. It said that it has achieved quantum supremacy by solving a problem which traditional computer would have taken 10,000 years to solve. Then quantum computers develop करने में there are 3 core challenges: interference, error correction and output observance. Interference we understand, unnecessary outside energy impacting our quantum bit. We would want that only our processor is able to change the quantum bit, but energy from outside is changing our quantum bit, that is interference. Error correction is like you remove these errors which has been brought in by the outside interference. That is a challenge. And reading the output observance is a challenge. These are 3 core challenges which quantum computing is facing. But in the last 20 years, a lot of development in quantum computers have taken place, and there is possibility that very soon, बहुत clarity नहीं है, very soon we may have a quantum computer. If Google has achieved quantum supremacy, more companies will achieve quantum supremacy, more advancement in technology, we may actually end up having a quantum computer very soon. There are some quantum computers like D-Wave System is a company which says that it is working on a quantum computer. Google has developed Sycamore, which is a quantum computer. Applications of quantum computers. So again, when we are talking about applications of quantum computers, we are basically talking about solving huge problems which current system are not able to solve. For example, simulation of molecules, transforming healthcare and medicine. How will we transform healthcare and medicine? In healthcare and medicine, what do you do? In medicine, you react various compounds to see what is the output, right? Now you will not need to do all those things in lab. You will be able to do all those things on a computer by simulation. If quantum computer is successful, so you will be able to come up with a lot of different new molecules in a much faster manner, new compounds in a much faster manner. And then advanced cryptography. With the coming of quantum computer, the current cryptography mechanism would fail. Will it fail? Yes, the current cryptography mechanism would fail, because current cryptography mechanism is based on the principle that very large numbers cannot be factored by the current computers. But quantum computer would be able to break that. But it will break the traditional cryptography, that's true. But it will also give you what is called quantum cryptography. And quantum cryptography is much more secure than the traditional cryptography. There are other civilian applications like DNA modeling, complex material science. Wherever you need a lot of calculations, no, quantum computers would be able to play a huge role. You know, so where do we use supercomputers in India? India के सबसे बड़े supercomputers कहाँ हैं? Weather forecasting. Because supercomputers need weather forecasting, where you need to do a lot of calculation. So quantum computers would also fast track what? Things like weather forecasting. Wherever you need lots of calculation, quantum computers would be able to help you do that. Teleporting the information from one location to another. Information, I'm not saying human being. है ना? कहीं बीटल्स का शो चल रहा हो, पारस बोले मेरे को सर वहां पहुंचा दो. यू नो बीटल्स नो? नहीं, हाँ पारस को पता है. और इंडिया का फेमस कुछ बताओ, कुछ शो. हाँ हाँ लोकल बैंड. हाँ ओके लोकल ट्रेन. अच्छा कोई बड़ा शो चल रहा हो, यू मे वांट कि यू शुड बी एबल टू गो एंड सी देयर. So we are not teleporting human beings, but with the development of quantum computers, with more advancement in the study of entanglement, quantum entanglement, you'll be able to teleport information from one point to another very easily. Where would you need to do it? Think of space exploration. Some of our explorations have gone beyond Pluto. हमारा मतलब नासा का. by R we are trying to say humans. but वहां तक कोई सिग्नल इलेक्ट्रोमैग्नेटिक वेव्स के फॉर्म में भेजना will take a lot of time. Do you know how much time does it take light to reach from sun to earth? Around 8 minutes. Right? So in future teleportation and all information sending and all those things would also be feasible. तो कंप्यूटर्स की सारी प्रॉब्लम सॉल्व करना, क्रिप्टोग्राफी इज यूज्ड एवरीवेयर, मिलिट्री में हर जगह. देयर हेल्थ सेक्टर कैन बी एनहांस्ड, मटेरियल साइंस सेक्टर कैन बी एनहांस्ड, वेदर फोरकास्टिंग कैन बी एनहांस्ड. So just understand huge problems to be solved. Wherever large processing power is a limitation, quantum computer would be usable there. Fine. What is going on in India? What is India doing to develop quantum computers? So in budget 2020-21, we launched National Mission on Quantum Technologies and Application, and government has allocated 8,000 crore rupees for it. This is the first major initiative that we have taken. इससे पहले वाला जो initiative था ना, Quest initiative 2018 में I think launch हुआ था. That was a joke because they had allocated 80 crore rupees for development of quantum computers and all, and 80 crore rupees आप समझ सकते हो. So this 8,000 crore rupees is also not enough, but at least 8,000 crore rupees over the next 5 years have been allocated. It would be sufficient fund. I can assure you this, Google में whoever is heading this quantum computer development project, only the head of that person must be getting a salary of more than 100 crore rupees. Rupees में बात करें. And when government allocates 80 crore rupees, so this is that's why I'm saying this is the first major initiative towards the development of quantum computer. National Mission on Quantum Technologies and Application, where 8,000 crore rupees have been allocated for 5 years. Although the amount is still low to begin with, but given advancement in technology and India's ability to create low-cost solution, the money may suffice. In August 2021, India also launched Quantum Simulator, QSIM, Quantum Simulator. Now, what is Quantum Simulator? We do not have quantum computers, but suppose there are students who want to do programming on quantum computers. A quantum computer तो है ही नहीं. So using some supercomputers, they have developed simulators which will behave like quantum computers, so that at least programming and all could be done. Like computer science वाले लोग कहाँ हैं? आप दोनों थे ना? So you must have done this on Windows system. You must have installed Linux का simulator. You have not installed Linux itself, but it's simulator, so that simulator you can do Linux का coding, Ubuntu का coding वगैरह on that simulator, right? ऐसा करते हैं हम कई बार. So this simulator has been developed, which will help students, which will help researchers to hone their programming ability and all. Like जैसे ट्रेडिशनल कंप्यूटर में प्रोग्रामिंग होता है, क्वांटम कंप्यूटर में प्रोग्रामिंग वुड नॉट हैपन दैट वे, राइट? तो जब तक क्वांटम कंप्यूटर डेवलप नहीं होता, इट डजंट मीन दैट आवर स्टूडेंट्स, आवर रिसर्चर्स शुड नॉट हैव अ सिमुलेटर. तो QSIM हैज बीन डेवलप्ड इन 2018, जो क्वेस्ट इनिशिएटिव था 80 करोड़ रुपीस वाला, इग्नोर इट. तो overall we can say that quantum computer is going to be the next big thing in technology, and India should not remain behind it and should put in more research efforts, more resources to ensure that India is also among the first beneficiary of quantum computing technologies. Fine, quantum computers सबको समझ में आया है अच्छे से. तो क्वांटम कंप्यूटर्स न्यूज में नहीं था, वो क्वांटम एंटेंगलमेंट वाज इन न्यूज, बट बिकॉज क्वांटम एंटेंगलमेंट, सुपरपोजिशन, ऑल दोस थिंग्स आर यूज्ड फॉर क्वांटम कंप्यूटर्स. So we have covered quantum computers also in a lot of detail. Computer and IT is in your syllabus. You should know about quantum computers as well. So we will do one more science and technology wala topic before we write an answer. We'll write an answer on quantum computing only. So you should know what is quantum computer, or what is quantum computing, what are its advantages over traditional computers, what are the key problems because of which development of quantum computing is difficult, what is India doing towards it, what more should it do, and conclusion. इससे ज्यादा क्या पूछेंगे बताओ? इससे ज्यादा what would UPSC ask if they ask quantum? Like even last year I had explained all these things. Entanglement को अभी Nobel Prize मिला है, but for those of you who have studied with me in the past, you must have studied entanglement before. हमने पहले पढ़ा है. तो we had studied all those things. एग्जाम में आया क्या? क्वांटम बिट है ना. तो UPSC is not going to go beyond what we have studied in quantum computing. तो ना, do not do a lot of research. and कई बार ना जैसे I'll tell you, मैं और निखिल सर हम दोनों एक जैसे थे. We would read a history book and we'll keep going in depth, rather than अरे भाई एग्जाम के लिए नहीं चाहिए, तो बहुत नॉलेज हो गया, एग्जाम का प्रिपरेशन नहीं हुआ. इन द सेम वे क्वांटम कंप्यूटिंग में अपीयर वेरी मजेदार फॉर अस कि यार इसे तो और समझना है. आई टेल यू, a few months back I ordered a MSc वालों का book on quantum computing. I have that book with me. क्योंकि इतना मजा आया इसे देख के, समझ के, पढ़ के. But we do not have to do that. You do not have to do that. This is your preparation for quantum computing. Fine. Let's go to the next Nobel Prize. Nobel Prize in Physiology or Nobel Prize in Medicine, which has been given to Swedish scientist Svante Pääbo. बोलो. देखो, again, when the molecules are not large, understand this, when molecules are not large, then number of interactions would be very less. So when you only have to break a nucleus in that kind of scenario, and this simulation will not be the nuclear bomb का जो simulators है, they are not actually worried a lot about this compound formation and all. There are some other form of simulation. Okay, come back to this. Svante Pääbo, a Swedish scientist who has got Nobel Prize for Physiology or Nobel Prize for Medicine. So before going into this, no, let us do something else. The next topic. वो इसका थोड़ा preparatory topic है, which I generally teach in history, but यहाँ पढ़ा रहे हैं. आप बोलोगे सर हिस्ट्री को साइंस में पढ़ा रहे हो. अंडरस्टैंडिंग द ओरिजिन ऑफ ह्यूमंस. ह्यूमन बीइंग्स 2 million years ago we were like this. 4 million years ago we were like this. 40 लाख साल पहले हम ऐसे थे. Unless you believe in mythology, Adam and Eve भगवान ने क्रिएट कर दिए और एकदम ऐसे ही गोरे चिट्टे से पैदा हुए, सोचो ना, ऑल आर बायसेस आर रिफ्लेक्टेड देयर। जब हम माइथोलॉजी पे जाते हैं ना, तो हम कि ब्राह्मण्स को भगवान के सिर से बनाया गया, all our biases are reflected there. All those things are not correct. All those things are mythology. Human beings on earth have evolved from other animals. Life started on earth around 3.5 million years ago. It started as a single cell, 3.5 billion years, 3.5 billion years ago. Earth was formed around 4.5 billion years ago. Sun was formed around 5 to 6 billion years ago. This universe started around 14 billion years ago. Big Bang Theory, Sun 4.55 billion years ago. Sun का भी एक limited life है. When in science and technology we'll study Sun, we would see that our Sun life would be around 10 billion years. Because it has hydrogen in it, वो hydrogen खत्म होगा ना कभी, fusion हो रहा है and all. Fine. In the same way, coming back to this thing, evolution of humans. The earliest known hominids, we are starting with hominids. Homo sapiens से पहले we are talking about hominids. Hominids are human-like species, were members of Australopithecus genus. Species in this group of early humans walked upright on a regular basis, but they still climbed trees. So these humans, the Australopithecus की जो हम बात कर रहे हैं, which lived around 4.4 million years ago. Please understand, 4.4 million years ago, there was no animal, no one on this earth who looked like us. We have only evolved 3-4 lakh years ago. We've only evolved 3-4 lakh years ago. Earliest hominids, Australopithecus, who looked like this, lived around 4 million years ago. 4.4 to 8 million years ago, 40 lakh साल पहले, we were this. They look like humans. We are saying that they're looking like humans. Even now, they did not have this scenario that they have longer legs and shorter hands. We have shorter hands, our legs are longer. They were not like that. They were still climbing trees. Fine. And they were not using any tools. Stone tools, etc. were also not being used by them. And they were not even of Homo genus. We are Homo sapiens. Sapiens is our species. Homo sapiens species hai, so Homo is our genus. They were not even in Homo genus. The first Homo genus वाले लोग थे Homo habilis. Habilis means hand-using man, who were first found in Kenya and Tanzania around 2 million years ago. The earliest stone tool have been found at Hadar in Ethiopia around 2.5 million years ago. Australopithecus did not use stone tools. Habilis may have used stone tools. Fine. Then Homo erectus, who lived 1.89 million, who evolved on Earth around 1.89 million is around 20 lakh years ago, around 18 lakh years ago. 1.89 million, 1 million is 10 lakh, 1.89 million is around 18 lakh years ago. They started and they lived up to 1 lakh 10,000 years ago. मतलब जब humans आ गए थे तब भी Homo erectus were there. When Homo sapiens had come around 3-4 lakh years ago, and they lived till 1 lakh 10,000 years ago. Or I should not say Homo sapiens had come, Homo sapiens had evolved. Homo sapiens had evolved around 3-4 lakh years ago, and they were also living on Earth at that time. Homo erectus, they first appeared in East Africa, from where they spread to various parts of Africa, Asia and Europe. They are earliest known humans to have possessed modern human-like body proportion. What is this modern human-like body proportion? Shorter hand, longer leg. Homo erectus were the first one to do it. Fine. Then Homo neanderthals. इन पे काम करने के लिए भी Nobel Prize मिला है. And that's why, like before coming to the Nobel Prize and all, I briefly wanted to talk about. And they are also our closest cousins, our closest brothers बोल देते हैं. If humanity, human beings को हम एक भाई कंसिडर करेंगे, भाई भी अगेन पेट्रियार्की, I have also read those books. I have also. So then are close. जैसे when we talk about Panthera tigris, तो Panthera genus में there are other species as well, right? In one genus you have multiple species. Even think of mosquito, Aedes aegypti mosquito. Do we know? Dengue transmission. Aedes genus में there are multiple mosquitoes, but Homo genus में there is only sapiens left. But till 40,000 years ago, we also had Neanderthals. They lived between 4 lakh to 40,000 years ago in Europe and southwestern Central Asia. They are sometimes also called subspecies of humans. Homo neanderthalensis, neanderthalensis और Homo sapiens neanderthalensis. Subspecies में क्या होता है ना, कई बार जैसे one species does not mate with other species. जैसे we are Homo sapiens and let's say Panthera tigris. You cannot mate with Panthera tigris, and even if you mate, you will not be able to produce fertile offspring. Gadha, Ghoda, they're different species. Even if they mate, they look very similar. If they mate, they'll not be able to produce fertile species. But there are evidences of mating and gene transfer between Homo neanderthalensis and Homo sapiens, and that's why sometimes it's said that they are subspecies and thus they are called, kahan gaye? Homo sapiens neanderthalensis. It's an extinct species or subspecies of archaic human that lived up to 40,000 years ago. Basically, let's say this was our parent species from which Homo sapiens and Homo neanderthalensis, we both evolved from this parent species. Fine. And 4-5 lakh years back, we evolved. They also evolved. They evolved a bit before us. Till 40,000 years ago, they were living on Earth. We were living together. They are known from many fossils. Neanderthals का बहुत सारे fossils आए हैं, and they were first located in Neander Valley of Germany, and that's why the name Neanderthal. Fine, comfortable. Whether the Neanderthals got merged into Homo sapiens or whether they became extinct remains a mystery. They are the closest extinct human relatives. A number of our relatives have ended their they have become extinct, but these are the closest ones. Then Homo denisovans. Homo denisovans, it is said, our parent species से Homo sapiens evolved, Homo neanderthals evolved, and then Homo neanderthals से ही एक और species separate हुआ, that was Homo denisovans. Denisovans पे एक क्वेश्चन आया था 2019 या 20 में, 19 में, because 19 में एक important discovery हुआ था. We'll come to that. Denisovans were not known आज से 20 साल पहले. They were not known. Hominin denisova was discovered by Swedish paleogenetist Svante Pääbo, जिसको अभी Nobel Prize मिला है ना. He discovered this hominin denisova. In 2012, he sequenced the DNA of well-preserved fragment of the bone that was 40,000 years old and was found in 2008 in Denisova cave in southern Siberia. Basically, I'll again sequence it. In 2008, in southern Siberia, there's a cave called Denisova cave. वहां पे एक होमिनिड का फिंगर का सैंपल मिला. इट हैड फ्रॉम द फिंगर बोन से some DNA could be extracted, and it was this scientist who extracted this DNA and sequenced this DNA to say, okay, ये कोई नया species है. It is a 40,000 year old sample, and this species you would see emerged 3,80,000 to 4,70,000 years ago. From whom? From Neanderthals. This was much later than the split between modern humans and Neanderthals. Modern humans और Neanderthals कब अलग हुए एक दूसरे से? From parent around 5-6-7 लाख साल पहले. उसके बाद, you remember that figure, parent से Homo sapiens and Homo Neanderthals. Then Homo Neanderthals से split हुआ Denisovans का. In the same cave, Denisova cave, paleontologists later discovered fossil of a girl who was part Neanderthal and part Denisovan. Sample of a girl who have been collected, some of whose genes are similar to Neanderthals, some of genes are similar to Denisovans, proving that these two species interbred. And thus again, these could be considered subspecies. Little is known about what Denisovans look like. You would notice carefully, यहाँ पे मैंने कोई image नहीं डाला. In case of Neanderthals, I had put an image. In case of Erectus, Homo erectus, I had put an image. In case of habilis, Homo habilis, I had put an image. In case of Australopithecus, I had. So they do not exist anymore. But we had found enough samples to determine, by their bone structure and everything, determine how they would look like. But Denisovans का तो पहला discovery 2008 में हुआ है. So we do not have enough samples to explain how Denisovans look like. Little is known about what Denisovans look like because they have left few fossilized traces of their time on Earth other than fragments found in Siberia and a jawbone discovered in Tibetan Plateau in 2019. You will see why in 2019 it was asked in examination. 19 or 20, why was it asked in the examination? Current Affairs. Denisovans न्यूज में थे, वो किस लिए न्यूज में थे, क्या है, इस तरह का कुछ क्वेश्चन आया था. ओके, for details we'll talk about 2022 physiology. Okay, then modern humans, ये है निशात सर अपने, है ना, ह्यूमन है ना, वैसे वो नाराज भी नहीं हो सकते कि why are you calling me Homo sapiens? What should I call you? Homo erectus? Homo habilis is a Homo sapien, right? So Homo sapiens look like this. We appeared in Africa around 3 lakh years ago and eventually replaced all homogeneous. 3 lakh years ago, there were many homogeneous species. Erectus was also there. Homo erectus were also there. Denisovans were there. Neanderthals were there. We emerged and then we are the only Homo species left. Note carefully, in conclusion, we are saying evolution is not a neat unilinear process. That is, ऐसा नहीं हुआ, from this emerged, from this emerged, from this emerged. There are overlap and coexistence of species. Fine? Comfortable? So, I just wanted to give you an idea कि human beings कैसे evolve हुए हैं. Now, we'll go to the Nobel Prize वाला thing. But also note one thing very carefully. First hominids का proof कहाँ पे है? Around 2 million years ago or 4 million years. Homo species. If you go to Homo species, it started 2 million years ago. When did life start on Earth? 3.5 billion years ago. 3.5 billion years. Billion is 10⁹. Humans, अगर हम अपनी बात छोड़े, हम तो 3 लाख साल पहले आए. लेट्स से फर्स्ट होमो स्पीसी वाला 2 into 10⁶ million years ago. So of all the time in which life has existed on Earth, we have existed only for this much time. And हम तो थे भी नहीं, I'm still using 2 million वाला years rather than only 3 lakh. We have existed only this much time. What is this time? इसे 3.5 को for calculation purpose let me make it. अच्छा इसे let it be 3.5. Let me make this 1.75. Half हो जाएगा ना? So basically if I do this calculation, it will be 1/2000. Am I right? 1/2000. तो अगर 2000 यूनिट ऑफ टाइम लाइफ पे अर्थ पे लाइफ एग्जिस्ट हुआ है, वी हैव एग्जिस्टेड ओनली फॉर, and then look at our narcissism. Look at our narcissism. The God who has created Earth looks like us. है ना? जब गॉड कोई मैसेंजर भेज रहा है, looks like us, वो गॉड का मैसेंजर। भाई, यू हैव एग्जिस्टेड ओनली फॉर 1 unit out of 2000, and someone who has created this earth looks like you, and their messenger looks like you. देख रहे हो अपना नार्सिसिज्म? राइट? कई रिलीजन में गॉड को कोई आकार नहीं दिया गया, बट अपने मैसेंजर्स तो उन्होंने भी ह्यूमंस ही बनाए ना। हमने तो अपने गॉड को ह्यूमंस का आकार दे रखा है, और फिर हम ही सबसे इंपॉर्टेंट है, वो वाली फीलिंग, नॉट रिस्पेक्टिंग अदर लाइफ फॉर्म, गिविंग वैल्यू टू योर ओन इंटरेस्ट। हमारा रिलीजन ही सबसे इंपॉर्टेंट है, वो वाला एटीट्यूड सारे रिलीजन में है, किसी एक रिलीजन में नहीं है। वी आर बेटर। क्रूसेड्स, मरो काटो। If we really understand science, if we really understand history, we would not be doing these silly things. We would not be doing these silly things. What silly things? Unnecessarily फालतू चीजों पे लड़ना। भाई, just imagine for how long we have been on earth. Okay, let's go back to the Nobel Prize. What was the Nobel Prize for? Nobel Prize जो अभी मिला है, it is given for sequencing of Homo Neanderthal genome and identification of Denisovans. Let's talk about Nobel Prize. Swedish scientist Svante Pääbo has been awarded Nobel Prize for Physiology for the year 2022 for his discoveries concerning the genomes of extinct hominids and human evolution. So, through his work, what did he do? He sequenced the genome of Neanderthals, an extinct relative of present day humans. Do we understand Neanderthals? I do not have to go into the details there. Okay. Second, he also discovered previously unknown hominin Denisova. We talked about Homo Denisovans. In 2010, he published the first Neanderthal genome sequence at the Max Planck Institute in Leipzig, Germany. Comparative analysis demonstrated that most recent common ancestor of Neanderthals and Homo sapiens lived 8 lakh years ago. Common ancestor of Neanderthals and Homo sapiens lived around 8 lakh years ago. वहां से हम दोनों निकले हैं, Homo sapiens भी, Neanderthals भी. Neanderthals themselves lived up to 40,000, 4,000, please do this correction, 40,000 years ago. They lived up to 40,000 years ago. Neanderthals lived up to 40,000 years ago. Then in 2008, what he also did, in 2008, a 40,000-year-old fragment of a finger bone was discovered from Denisovan caves. पढ़ा था हमने अभी? His team was able to sequence that and also say that this is a different species named Denisova. Through his groundbreaking work, he has developed altogether new discipline called paleogenomics. What is genome? Genetic study कर रहे हैं, gene sequencing कर रहे हैं, but किसका? स्टोन एज वाले लोगों का. पेलियो स्टोन नहीं, ओल्ड पेलियो ओल्ड लिथिक, हाँ लिथिक इज स्टोन, पेलियो ओल्ड पुराने वाले लोगों का जीन सीक्वेंसिंग कर रहे हैं. तो ही हैज डेवलप्ड अ न्यू सब्जेक्ट ऑल टुगेदर, न्यू एरिया ऑफ स्टडी ऑल टुगेदर. ही इज कंसिडर्ड द फादर ऑफ पेलियोजेनोमिक्स. His most important contribution has been developing research methodologies to extract DNA samples from very old remains. कोई एक फिंगर पीस मिल गया उन्हें किसी केव में, from there he has been able to extract DNA. So scientifically this is his contribution. Extracting this DNA, studying that is his contribution. Following his initial discoveries, this group has completed analysis of several additional genome sequences from extinct hominids. Now, what are some of the findings? जब हम डेनिसोवंस को पढ़ रहे हैं, निएंडरथल्स को पढ़ रहे हैं, वी हैव रियलाइज्ड दैट वी हैव इंटरब्रेड विद देम. We interbred with Neanderthals, we interbred with Denisovans. Because some of our genes, people outside Africa have 1 to 2% of Neanderthal genes. जो लोग humans अफ्रीका के बाहर रह रहे हैं, they have 1 to 2% of Neanderthal genes. Sub-Saharan अफ्रीका के जो लोग हैं, they do not have any Neanderthal genes because Neanderthals never went to Africa. They evolved outside Africa and remained outside Africa. Their parents may have come from Africa, but they evolved outside Africa. तो outside Africa जितने भी humans हैं, they have 1 to 2% of Neanderthal genes. Similarly, Denisovans के केस में हम देखेंगे, Denisovan genes have been found in up to 6% of modern humans in Asia and Southeast Asia. Asia and Southeast Asia में up to 6% of genes are similar to Denisovan genes. What does it say? It says that we इंटरब्रेड. तभी जीन ट्रांसफर होगा. जब बायोटेक्नोलॉजी तो था नहीं कि उनका जीन निकाल के इसमें डाल दिया, है ना. जेनेटिक इंजीनियरिंग had not been developed then. So we were interbreeding, and that's why they may be subspecies. They may be considered some species also. Now these genes are playing a lot of role in today's human beings. It influenced the physiology of present day humans. For example, Denisovan का एक जीन है EPAS1. It confers advantage of survival at high altitude and is common among present day Tibetans. This gene is crucial for survival in high altitude, Denisovans का, and it is found in Tibetan people. Similarly, Neanderthal genes affect our immune response to different types of infection. COVID-19, some of the genes that we have taken from Neanderthals made us susceptible to COVID-19, and there are other genes from Neanderthals only which have made us immune. Nobel Prize तो 2022 में मिला ना. In 2020 and 21, the scientist who got Nobel Prize published 2 research papers. In the first research paper, he showed how one particular gene from Neanderthals aggravated the risk of severe disease among COVID patients. In 2020, he had published this paper. In 2021, in the other paper, he showed that another gene from Neanderthal was possibly offering protection against severe COVID. So we can say, at the time when Homo sapiens migrated from Africa, we have all migrated from Africa. When we migrated from Africa, at least 2 extinct hominin population inhabited Eurasia: Neanderthals and Denisovans. At least 2. But as we have seen, Homo erectus also lived up to 110,000 years ago. They may also have been there. There are some other small species who may have existed, but at least these 2 were there with whom we interbred. Neanderthals lived in Western Eurasia, whereas Denisovans populated eastern part of the continent. During the expansion of Homo sapiens outside Africa and their migration east, they not only encountered and interbred with Neanderthals, but also with Denisovans. For this work, he has been given Nobel Prize. Nobel Prize किस लिए? Nobel Prize है जो इतने पुराने सैंपल्स हैं उनसे जीन एक्सट्रैक्ट कर पाना, जीन सीक्वेंसिंग कर पाना, and then that gene sequencing has given us a lot of information. एंथ्रोपोलॉजी ऑप्शनल किन लोगों का है? कुछ लोग हैं, तो आपके लिए भी रेलेवेंट होगा ये, राइट? यू पीपल स्टडी दीज थिंग्स. वन मोर थिंग, Plabo father had also won Nobel Prize in 1982 for physiology only. So they are only the 6th father-son pair to have won a Nobel Prize. And मुझे मैंने बहुत ऐसे उड़ते उड़ते पढ़ लिया था. This scientist was also Plabo Plabo was also not a legal son of the scientist. Legal son मतलब extramarital affair से. In his biography or something, he himself has mentioned that. एनीवेज नॉट वेरी इंपॉर्टेंट, मैं थोड़ा और पढ़ लूंगा तो ज्यादा कॉन्फिडेंटली बता पाऊंगा पूरी स्टोरी, बट साइंटिस्ट ऑल्सो हैव एक्स्ट्रा मैरिटल अफेयर्स। ओके, तो फिजियोलॉजी आप क्यों हंस रहे हो, आपकी तो शादी भी नहीं हुई, पहले प्री मैरिटल तो कर लो। प्री मैरिटल हो नहीं पा रहा, एक्स्ट्रा मैरिटल की बातें कर रहे हैं। कहाँ थे हम? अफेयर्स पे नहीं, करंट अफेयर्स पे। दी नोबेल प्राइज इन फिजियोलॉजी, आई होप सबको समझ में आया। इट्स इंपॉर्टेंट दैट वी स्टडी इट विद ह्यूमंस का एवोल्यूशन, because we understood Neanderthals, we understood Denisovans, and where they fit, we were able to understand how Svante Pääbo's work could have been was helpful to understand humans' connection with them, humans' evolution, and how our health today is impacted by our interaction with those species then. Fine, let's now go to GS2. अब हम parliamentary कमिटीज से स्टार्ट करते हैं। देखो यहाँ पे आई हैव अ रिक्वेस्ट, यू स्टडी द डिटेल्स ऑफ पार्लियामेंट्री कमिटीज, like which parliamentary committee has how many members, from which Lok Sabha or Rajya Sabha it comes. All these things are mentioned in Lakshmikant. As I request you two things, other than current affairs in GS2 and GS3, you have to do two things. One, basics of polity from Lakshmikant or DD Basu, whichever you prefer, and two, basics of economy from Shankar Ganesh or Vivek Singh Sir's book, whichever you prefer. वो बेसिक दो चीजें कर लीजिए, बाकी GS2 and GS3 in this program is my responsibility. Fine. So in when I'm talking about parliamentary committees, I will not go into each committee and their formation and their membership and all those things. That you have to study at your own. Go home today and even today only read the chapter on Lakshmikant where they're dealing with parliamentary committees. But here we'll start with the fundamental aspect. What are parliamentary committees and why they are needed before we get into types of parliamentary committees and all. See, let's say we are parliament. ये contempt तो नहीं हो जाएगा ना parliament? Let's say we are parliament and we have to go through various bills. If all of us were sitting and going through each and every aspect of bill, it will take a lot of time, right? And it won't be possible for us to work effectively. Not all of us may be expert in science, so science and technology associated कुछ आ रहा है, all of us are wasting our time because we'll not be able to have our say. Not all of us may be expert in economy, not all of us may be expert on social issues, and we are sitting for everything, then nothing would be done. So parliamentary committees are panels created from within the parliament to deal with the increasing workload and specialized nature of knowledge required for dealing with issues. For example, information and technology के लिए एक parliamentary committee बनी हुई है. So if a bill comes on information technology, it can be analyzed by the department related standing committee on the information and technology. Ethics के लिए एक parliamentary committee बनी हुई है. An issue related to ethics occur, that parliamentary committee does its study. There's an estimates committee which will go through the budget proposals of various ministries and will give suggestion ki how those proposals could have been made more effective. There is public accounts committee which will go through the CAG report. Now CAG reports are huge. If all of us sit here, like if we are the parliament, we sit here and go through every aspect of CAG report, then a lot of other works would not be done. So PAC will study the CAG report and would submit its submission to the parliament. These are our findings. Okay, so what is parliamentary committee? A parliamentary committee is a panel of member of parliaments that is appointed or elected by the house or nominated by the speaker and which works under the direction of the speaker. Why is it needed? The work done by parliament in modern times have become very varied and complex in nature and considerable in volume. It therefore can't consider all legislative and all matters that come before it, a good deal of work is being done in parliamentary committees. There are two broad categories of parliamentary committees: standing committees and ad hoc committees. Standing committees are those committees which are always there. Okay, standing committees can further be divided into financial committees. Jisme estimates committee, public account committee, committee on public undertaking is there. There is department related standing committees. So for every ministry, there are 24 department related standing committees. So a bill related to a ministry comes, उस पे specialized study करना है, it will go to those department related standing committees. Then there are other parliamentary standing committee like ethics committee and all. They are neither financial nor department related. They are dealing with business advisory committee and they are dealing with other aspects, but they are also standing committees, that is they would be there, or they are always present. Then there are ad hoc committees. Ad hoc committees are ad hoc in nature. They are made for some special purpose. For example, a bill comes, उस bill को study करने के लिए एक select, rather than the bill going to the department related committee, एक select committee could be created by Lok Sabha, or a joint parliamentary committee could be created by Lok Sabha and Rajya Sabha together for studying that particular bill or for dealing with a particular issue. Once that issue is done, once that bill is done and they have submitted its report, what happens? The committee ends. These are ad hoc committees. Okay, now let's talk about significance of the committee. Why these parliamentary committees are very important. Why is it in news? ये तो आप सबको पता है. Recently, parliamentary committees have been formed, and Congress, which is the main opposition party, has been made head of only one committee. Trinamool Congress, which is the second largest opposition party, has not been made head of any of the committees. तो इस वजह से कुछ न्यूज़पेपर आर्टिकल्स थे कि पार्लियामेंट्री कमिटीज, उनका सिग्निफिकेंस, उनका रोल क्या होता है, एंड क्यों ऑपोजिशन शुड आल्सो बी गिवन वैल्यू इंक्लूडेड इन इट. Anyways, so that was the news. So वो news as such is not important, but parliamentary committee क्या है, उसका significance क्या है, what can be done to improve its effectiveness, these are important aspects for your mains examination GS2 section. Now come back to increasing parliamentary scrutiny. See, parliament, if we all start going through, if the entire parliament starts going through each and every provision of the bill, they'll not be able to do work effectively. A lot of things would remain pending and would then just get passed without any scrutiny. But here, when you create specialized committees to deal with individual work, does parliament scrutiny goes up, increases? Yes, and that is the work of parliament. Parliament should hold government accountable. When government is introducing a bill, parliament should be able to study every aspect of it. Parliamentary committees help us in doing that. When we talk about let's say पब्लिक अकाउंट्स कमेटी जो सीएजी रिपोर्ट सबमिट करेगा, सीएजी रिपोर्ट जिनके पास जाएगा, that public accounts committee will go through CAG report in detail and then would raise questions, will ask ministers to come in front of them and say कि ये गड़बड़ क्यों हुई. Or through all this, what are they ensuring? They are ensuring accountability, they are ensuring parliamentary surveillance. That is a very important role of parliamentary committees. Then MPs get more time and wider role in examining important legislations. How? In Lok Sabha, when there is debate going on, BJP gets some time, Congress gets some time, and they choose कि ये leader बोलेगा, ये leader बोलेगा. Not everyone gets time to speak, gets time to present their views. Here, they'll be able to have more say in parliamentary work. Third, they can speak more independently here. Parliamentary committees meeting do not happen on camera, which happens in case of Lok Sabha, which happens in case of Rajya Sabha. So there are political reasons, there are politically difficult steps that need to be taken. So in front of your constituents on live TV, you will not be able to say that, but here you will be able to present your views more effectively. In fact, Woodrow Wilson, one of the former president of USA, had said this about committees. Congress in session is Congress in public exhibition. Unka parliament is Congress. So parliament in session is parliament on public exhibition, while Congress in its committees. Committee rooms is Congress at work. So it is basically, Woodrow Wilson is saying कि it is parliamentary committees which are doing work. Baki Lok Sabha, Rajya Sabha are for show purpose, exhibition purpose. Then parliamentary committees ensure expert consultation. A committee can call experts to understand various aspects of a particular issue, which would not happen in case of Lok Sabha. Lok Sabha में कोई scientist जाके कुछ बता रहा है, ऐसा नहीं होता, है ना? It facilitates interministerial coordination. It can consult different ministries. It involves opposition parties as well, and thus is able to build consensus among different parties. In these committees, opposition members would also be there. They'll be able to talk about their issues, concerns more effectively. Building, it is not constrained by parliamentary calendar. Parliamentary calendar में parliament meets around 100 days in 365 days. Parliamentary committees पे ऐसी कोई limitation नहीं है. Inter session period में भी they can meet. Monsoon session and winter session के बीच में जो break है, अभी right now I think we are going through that break. Parliamentary committees would meet here and would do their study, would publish, would prepare their reports and do all those things. So they have more time to do work. Then when parliamentary committee investigates something and when they are calling someone to be present in front of them, that letter is equivalent to a court summon. So an invitation to appear before a parliamentary committee is equivalent to summons from a court. If one cannot come, she must give reasons which the panel may or may not accept. All these things eventually lead to better laws, better policies, better schemes. Because opposition is also taken into consensus, consultation takes place, experts also come into play. So the laws which are eventually prepared are keeping in mind more stakeholders and thus are more inclusive, more effective, less contentious. One reason farm laws, 3 farm laws were passed, but they had to be repealed. They never went to parliamentary committees. And thus farmers' viewpoint of opposition, viewpoint of experts could not be taken. First, those were brought in through ordinance and then वो लोकसभा में पास कर दिए गए, राज्यसभा में पास कर दिए गए. That was an example of why parliamentary committees and their work are very crucial. Parliamentary committees' work is very important. We have seen the advantages, significance of parliamentary committees, but in last few years, their role has reduced a lot. You would see that in 14th Lok Sabha 2004 to 2009 and 15th Lok Sabha 2009 to 2014, UPA regime के दो terms, around 60% and 71% of the bills had gone to the committees. But in the 16th Lok Sabha 2014 to 2019, only 27% of the bills have gone to the committees. And sending bill to committees is not giving a lot of power to opposition. Most of these committees have majority of the ruling party only. But still governments are not, the Lok Sabha and Rajya Sabha is not sending bills to committees. तो एक आर्टिकल आया था रिसेंटली कि आर पार्लियामेंट्री कमिटीज effectively able to work. One reason they are not able to work effectively is because not enough number of bills are going to them. This may have led to deterioration of lawmaking. It is alleged that bills which are not examined properly, especially from the perspective of consumers and stakeholders, and remain just a bureaucratically conceived piece of legislation. If किसी मिनिस्टर ने बिल इंट्रोड्यूस कर दिया and it is backed by Prime Minister and the Home Minister, and everyone is just saying yes, 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 and the bill gets passed. Who made that bill? Some bureaucrats made that bill, right? So if we are not properly scrutinizing laws, then it is what? It is just a bureaucratically conceived piece of legislation, nothing else. A lot of other stakeholders, their viewpoint, their concerns have to be taken in. Okay, so what should be done? What should be done to enhance the role of parliamentary committees in the functioning of the parliament? One suggestion that is being given, recently I was reading an article which said that we can make it compulsory that every bill goes to parliamentary committee, except in some situations where exception could be provided, but in general, let's make it mandatory that bill automatically goes to the parliamentary Second, in the parliamentary committee discussion, let's whip wala rule not be applicable. तो पार्टी विप के अकॉर्डिंग ही आपको डिबेट करना है पार्लियामेंट्री कमेटी में. लेट दोस थिंग्स नॉट बी एप्लीकेबल देयर. लेट दोस थिंग्स आर एप्लीकेबल इन लोकसभा एंड राज्यसभा, राइट. वहां पे विप का कोई रोल होना नहीं. दे शुड बी एबल टू डिस्कस एनीथिंग. Discussion in the parliamentary committee should be frank and free. For this, it may be provided that no whip of the party would apply on the discussion of committee meeting. Third, fixed timeline should be given to committees to come up with their reports, their suggestions. Ministry of Parliamentary Affairs should work with head of these committees to ensure that in the intersessional period they are meeting effectively. Generally क्या होता है, जब सेशन पास आ जाएगा ना, winter session, then these MPs will come and meet and will finalize their report, and those reports also don't turn out to be effective. So it is important that they are meeting throughout the period and preparing their reports. Then increase consultation with experts. Though they can call experts and seek their viewpoints, but here a suggestion that is being given is it would be valuable if some subject experts could be associated with the committee for a short term. For example, let's say department related standing committee है on IT, on science and technology. Why don't we एक तो consultation के लिए just बुला रहे हैं, let them be associated with the committee for short period. Then widen the scope of recommendations of the committee. These committees should not only deal with the bill which has been presented to them and all, they should be able to give out of box suggestion for the welfare of people. Now these recommendations are not mandatory. Lok Sabha may reject it. Lok Sabha may ignore it altogether. Rajya Sabha may ignore it altogether. But they should be able to give wider forms of suggestion for effective law making, for effective policy making, for effective governance. These are some of the things by which the role of parliamentary committees would become more effective. More involvement of parliamentary committee is crucial for good law making, and presiding officers may in public interest refer all important bills to the committee with few exception. अच्छा, ये conclusion थोड़ा वो हो गया है. This conclusion I may have written when these suggestions were not there in way forward. अब way forward में हम बोल रहे हैं कि भाई make it compulsory, then this conclusion may not be relevant where we are requesting the government, the speaker to refer all the bills there. Okay, anyways, coming back to parliamentary committees, इसका मेंस वाला सारा सेक्शन हमने पढ़ा. प्रीलिम्स का सेक्शन जैसे इन स्टैंडिंग कमिटी वी हैव फाइनेंशियल कमिटीज, तो उसमें पीएससी का फंक्शन, एस्टिमेट्स कमेटी का फंक्शन, बाकी कमिटीज का फंक्शन, पब्लिक अंडरटेकिंग वाली कमेटी का फंक्शन, कितने मेंबर्स होते हैं, सबसे ज्यादा मेंबर्स किसमें होते हैं, all those things which are relevant for preliminary examination, please go through for those things go through लक्ष्मीकांत और डीडी बसु. उसमें पार्लियामेंट्री कमिटीज वाला जो चैप्टर है अच्छे से एक बार पढ़िए. वहां पे ये चीजें मेंशन नहीं होंगी जो हमने वे फॉरवर्ड में पढ़ा है ना, वे फॉरवर्ड में पढ़ा है, या प्रॉब्लम्स वाली चीज पढ़ी है. प्रॉब्लम्स उन्होंने कुछ प्रॉब्लम्स बताई होंगे बट लेटेस्ट डेटा में नॉट बी देयर, एंड वे फॉरवर्ड इज नॉट देयर इन लक्ष्मीकांत. जो मेंस में हमें प्राइमरली लिखना होता है दैट इज नॉट देयर, दैट यू विल स्टडी फ्रॉम हेयर, बट जो बेसिक्स है आपको वहां से पढ़ना. ठीक है, एंड प्लीज मेक श्योर इन योर ऑब्जेक्टिव टेस्ट विच वुड हैपन नेक्स्ट वीक, वी वुड इंक्लूड द इवन दैट पोर्शन, द बेसिक वाला पोर्शन. तो यू स्टडी द मेंस वाला थिंग हेयर एंड बेसिक थिंग्स फ्रॉम देयर. Dipanshu is saying major reports of all committees should be discussed in parliament, especially in cases where there is disagreement between a committee and the government. The recommendations of the PSC should be accorded greater weight and they must be treated as conscious keepers of the nation in financial matters. These are some other suggestions which Dipanshu is giving. Done. Let's go to the next topic, Indian diaspora. Indian diaspora. अगस्त में एक मेजर इंटरनेशनल रिलेशन वाला इशू था विच वी हैड मिस्ड, पार्लियामेंट्री कमेटी ऑन एक्सटर्नल अफेयर. देखो ये पार्लियामेंट्री स्टैंडिंग कमेटी होते हैं ना, डिपार्टमेंट रिलेटेड स्टैंडिंग कमेटी, वो पार्लियामेंट्री कमेटी ऑन एक्सटर्नल अफेयर्स सबमिटेड इट्स रिपोर्ट ऑन वेलफेयर ऑफ इंडियन डायस्पोरा पॉलिसीज एंड स्कीम एट द बिगिनिंग ऑफ अगस्त 2022. दिस वी हैड नॉट कवर एंड दैट्स व्हाई आई वांटेड टू कवर इट हियर. अच्छा, व्हेन वी टॉक अबाउट इंडियन डायस्पोरा, हु आर द पीपल हु आर इंक्लूडेड इन इंडियन डायस्पोरा? इंडियन डायस्पोरा में कौन कौन लोग होते हैं? एक हाथ उठाओ और बताओ, आप बताएंगे, आप नाम बताओ पहले। ओमेंद्र, हाँ बड़ा कंफ्यूजिंग नाम है इसका, ओमेंद्र। ओम बोल सकते हैं, ओम जी बताइए। वेरी लिमिटेड डेफिनेशन। और एनी देखो इंडियन डायस्पोरा में ना देयर वुड बी टू कैटेगरी ऑफ पीपल। वन, एनआरआईस, इंडियंस हु आर लिविंग आउटसाइड इंडिया, दे आर इंडियन सिटीजन्स, दे आर लिविंग आउटसाइड इंडिया, दे आर इंडियन डायस्पोरा के पार्ट। देन पीपल ऑफ इंडियन ओरिजिन, people of Indian origin could be people who left India at the time of British rule. वो कहीं चले गए हैं, वो लेट्स से मॉरिशस में रह रहे हैं, they are of people of Indian origin, they have citizenship of some other country, they're following culture of some other country, but they are people of Indian origin and they're part of Indian diaspora. Some of us may have migrated in 1960s and they have become citizens of some other country, even they are part of Indian diaspora. So there are citizens, there are non-Indian citizens who are people of Indian origin, they are also part of Indian diaspora. So according to this parliamentary committee, there are 31 million people who form part of Indian diaspora. 31 million people, 3 करोड़ लोग हैं जो इंडियन डायस्पोरा का पार्ट फॉर्म करते हैं. आउट ऑफ देम अराउंड 13 million NRIs are there, around 13 million, 1.3 crore Indians who are living, 13 million, 1.3 crore, 1.3 crore Indians, people who are holding Indian citizenship and are living outside India. And there are 18 million person of Indian origins. Now please note, NRIs are also of Indian origin, but उनको और higher status है, they are Indians. They are non-residential Indian, non-resident Indians. And these are the people who are not Indians, but people of Indian origin. They are Indian diaspora. So in general, we can say that people who migrated from territories that are currently within the borders of Republic of India and their descendants. So even the NRIs have migrated, and people who migrated from this region and are living somewhere, and their descendants, they're living somewhere else, they are diaspora. Okay, now why is diaspora? इंटरनेशनल रिलेशन में 4-5 बुलेट पॉइंट्स दिए हैं, उनमें एक स्पेशल बुलेट पॉइंट इज ऑन इंडियन डायस्पोरा. हमारे लिए तो वो यूपीएससी के सिलेबस में स्पेसिफिकली मेंशन्ड है अलग से. इट मेक्स इट वेरी इंपॉर्टेंट फ्रॉम एग्जाम पॉइंट ऑफ व्यू, बट इट ऑल्सो गिव्स अस एन आइडिया कि हाउ सिग्निफिकेंट दैट टॉपिक इज, हाउ सिग्निफिकेंट दैट इशू इज. व्हेन इन द सिलेबस ऑन इकोनॉमी फूड प्रोसेसिंग इंडस्ट्री स्पेसिफिकली मेंशन्ड, इट टेल्स अस that it's very crucial for India's growth and development. Why only food processing industry has been mentioned? Why not other kind of industries? Because food processing industries have a lot of scope. In the same way, Indian diaspora is very significant for India. That's why UPSC के syllabus में इतना importance दे रखा है उसे. PIO, OCI, we are coming to this. PIO, OCI, वो सारी चीजों पे आते हैं, है ना. Importance of Indian diaspora. First, let's talk about paisa. They get us a lot of money. India is the biggest remittance receiver in the world. Abhi July mein WHO published a report which said that India received $87 billion last year, which is the highest any country has received from its citizens and diaspora living outside. Then diaspora also invest a lot of money. So economically they are beneficial, but in social sector also they contribute a lot. NGO Pratham, जो कि असर रिपोर्ट पब्लिक करता है, असर रिपोर्ट हैज अ लॉट ऑफ क्रेडिबिलिटी. असर टॉक्स अबाउट द लर्निंग एबिलिटीज ऑफ चिल्ड्रन और हाउ इफेक्टिवली चिल्ड्रन इन इंडियन स्कूल्स आर लर्निंग. Pratham NGO was provided substantial contribution from 2 NRIs living in US, and it was with their help Pratham had grown like anything. Similarly, LV Prasad Eye Institute, people who have lived in Hyderabad would know about the significance of this institute. It was also established by an NRI. So these indicates that these are some examples, but there are lots of contributions which people of Indian origin or other NRIs are making in the development of the country. It's not only economic, even in social sector, they contribute a lot. Then they lobby for India's cause abroad. For example, establishment of Indian caucus in the House of Representatives, and it's played an important role in India-US nuclear deal. In 2006-7, it was Indian origin MPs in the US Parliament. They formed a group for supporting India for playing a role for India's development. Then they promote India's culture abroad. They build a good image of India wherever they go. हम बहुत proudly बोल पाते हैं, अरे Microsoft, Google, they're all being headed by people who are from India, right? So that image of India. But India's diaspora policy has changed a lot over the years. Diaspora, Indian diaspora is significant. It has India's diaspora policy has evolved and changed a lot over the years. At the time of independence, government of India, or at the time of Nehru, in the Nehruvian model, Indian diaspora, we did not engage a lot with Indian diaspora. We did not play, we were not keeping a strong bond with Indian diaspora. There were different reasons for it. Politicians at that time thought that if we champion the cause of overseas Indians, then it might offend the host countries. And it may make life difficult for Indians who are there. For this reason, they are Indians and they will work for us, they will benefit us, we will benefit them, we are looking after them. US would be like, we can take care, through our labor laws, we can take care of them. You don't worry about us. This was our attitude. Indian community and other diplomatic missions interacted on national days or other important cultural occasions, but diaspora diplomacy was very low-key. It changed with Rajiv Gandhi. For the first 2-3 decades, we were like not having strong diaspora policy or strong interaction with them. It changed with Rajiv Gandhi. Rajiv Gandhi wanted to follow the Chinese model. Chinese diaspora played a very important role in the development of China in 1980s and 90s. A lot of them who had gone outside, they were called back in the field of science, in the field of technology, in other fields. They were given opportunities and made to contribute in the development of China. Similarly, Rajiv Gandhi wanted, from the time of Rajiv Gandhi, we started interacting with diaspora more. Indians from abroad, regardless of their nationality, were made to participate in nation building, much like the overseas Chinese community. Isme Shyam Petroda comes as a very big example. He is considered someone who played an important role in making IT industry develop in India, in making policies, schemes, programs, so that India is able to, India does not remain behind in IT or software sector. It was his contribution that world की जो 5 biggest IT companies की जब बात होती है उसमें 2-3 Indian हो जाते हैं. Like the biggest IT company I think is Accenture, which is US based, but after that TCS, Infosys, all these companies come. And there were other factors which kept on making these bonds stronger. We would see increased number of Indian migrating to West Asia and other Western countries in 1990s. Liberalization, privatization, globalization reforms took place. We were more open now. We were more, so a lot of Indians were going abroad. Domination of Indians in global IT revolution also played a role in evolution or in changing of Indian diaspora policy. Then there was an increased understanding of significance of Indian diaspora in various fields. Government realized that they can contribute a lot in India, India's growth, India's development, which was not the realization in 1950s and 60s. And our policies changed, our initiatives changed. A number of initiatives have been launched since then. In fact, since 2014, we have become, our bonds with Indian diaspora have become much more stronger. Prime Minister Modi has made diaspora centerpiece of his foreign policy. And a number of initiatives we have launched. 1990 से अब तक we have launched a number of initiatives for the strong bonds between India and Indian diaspora. Pravasi Bharatiya Divas started in 2003. हर साल जनवरी में we have this where we interact, where we promote our interaction with Indian diaspora. Overseas Citizen of India card was system was brought in. In fact, पहले ना इंडिया में दो कार्ड होते थे, पर्सन ऑफ इंडियन ओरिजिन कार्ड एंड ओवरसीज सिटीजन ऑफ इंडिया कार्ड. देखो, there are citizens there are people who are Indians. They can come to India at any number of times. They can stay in India for any amount of time. They can invest in India. They can do everything in India. Fine. But people of Indian origin, person of Indian origin, उनके पास अनलिमिटेड नंबर ऑफ इंडिया में एंट्री के वीजाज नहीं होते थे, है ना. तो PIOs and OCI were two different kinds of card holders who were given some benefits. OCIs had much more number of benefits when compared to PIOs. बाद में गवर्नमेंट merged PIO and OCI, basically they made everyone OCI. So OCI has much more number of benefits. So it allows easier investment. It allows easier coming and going back from India. You can come to India any number of times. Those kind of things are there. So Overseas Citizen of India card system was brought, and then it was merged with PIO to increase India's bond with its diaspora. Then there was a Ministry of Overseas Indian Affairs. It was also merged with Ministry of External Affairs to give a more holistic approach to India's diaspora policy or India's interaction with its diaspora. Why? Because Ministry of External Affairs, Foreign Ministry, if overseas Indians से related कोई work है, if this Ministry of External Affairs itself is dealing with it, then will it not be able to cover it in a more holistic manner? Yes. It is meeting, Ministry of External Affairs is interacting with External Affairs Ministry of USA, जहाँ पे उसे क्या बोलते हैं, State Department बोलते हैं. So it's interacting with them. There it can raise the issues related to overseas Indians, right? So these were also merged. Voting rights were given to Indians who are not residents here. जो Indians NRIs हो गए हैं, उनको voting rights were given by Amendment of Representation of People Act. Now Indians who are living abroad can also come to India and vote. अभी तक e-voting and those kind of mechanisms have not been developed, but voting rights have been provided to them. We have signed bilateral social security agreements with a number of countries. Now, what is this bilateral social security agreement? Currently, when you work in India, आपका PF कटता है. That is supposed to benefit you when you retire. In the same way, when Indians go abroad for, let's say, short period, for 5 years or 10 years, उनका PF कट रहा है, which would benefit them when they retire, but they are not retiring in that country. They are going to come back to India and retire. Then why is unnecessary deduction is taking place there? So this bilateral social security agreements provided that this would not happen. This unnecessary deductions would not happen. Will it benefit Indian diaspora? Yes, it will at least benefit that Indian diaspora which is planning to come back to India. Okay, then there are other initiatives we have launched. We have launched Madad portal, e-migrate portal, Indian community welfare funds. These initiatives, prelims के लिए थोड़ा details भी देखने पड़ेंगे इनके, mains में. These are some of the initiatives that we have launched. Then during difficult times, we go for active evacuation. Our Vande Bharat mission at the time of COVID-19 evacuated around 8 lakh people of Indian origin, people of Indian diaspora. Operation Sankat Mochan was launched, which airlifted citizens stranded in South Sudan's capital, Juba, when it was facing war and all. So we have been taking a lot of steps to enhance India's connection with India's diaspora, to take care of Indian diaspora. But still, there are lots of problems, lots of issues. Some of the issues have been highlighted in the report which has been published in August by the Parliamentary Committee. The Parliamentary Committee says that India does not have a clear-cut diaspora policy. What is meant by India not have, like, we do not have a policy document which has highlighted the principles which will follow for our diaspora. So when Indians were being evacuated at the time of COVID-19. There are people who are raising questions. You're not doing anything for migrant workers who are working within the country for the country. They are walking alone on the roads, and you're spending a lot of money for evacuating them, and government was not able to defend it by saying ki bhai, this is our duty, this is our policy, we have been following that policy. We do not have a policy as such, well, policy document which has enunciated the principles. Parliamentary committee says that in the absence of that, today you will do something, tomorrow you will do something else. Second, we do not have an authentic database. And what happens is, जब crisis आता है तो embassy of a country is being asked, identify who are Indians. We'll have to evacuate them. How many people of Indian origin, how many people of Indian diaspora are living in which country, what are they doing, those kind of information we do not have. तो उनसे interact करना भी मुश्किल होता है. In emergency situation उनको evacuate करना भी मुश्किल. These challenges come into play. There are other issues. Some recent issues are a number of COVID-19 returnees are facing problems. Some of them have gone back, but many of them have not been able to get their jobs back. Many of them are not able to return back because of the stringent visa policy which has come into play. Many of them were students whose 2 to 3 years have been affected. There are students who are doing their medical science preparation, or sorry, medicine studies in China. बहुत सारे इंडियन स्टूडेंट्स चाइना में जाते हैं MBBS करने के लिए. Why? इंडिया में इतनी सीट्स नहीं है एंड बहुत कंपटीशन होता है एंड सस्ता भी हो जाता है वहाँ पे. इंडिया में इफ यू हैव टू गो, बिकॉज देयर आर लेस सीट्स, इफ यू वांट टू गो बाय डोनेशन एंड ऑल, फी इज वेरी हाई मेडिकल साइंस में. So a lot of people go to China, but during COVID-19 restrictions, when they had to come back, unlike MBA and all where you can do your work online, in MBBS you cannot do that. Practical work has to happen in the hospital. So a lot of these people are still facing problems. Then this happened, Ukraine war. Doctors who have come back from there, the students who have come back from there, many of them were doing studies in medical science. They're not able to continue their studies. Indian government will not be able to get them admission in India. Why? Because there are lots of aspirants in India who could not get admission because they didn't get good rank. Then why these people would get admissions? ये concerns हैं, but what happens to them? Indian diaspora is facing issues, Indian diaspora is facing concerns. Then there is another criticism that is made of India's interaction with its diaspora, is that we are biased towards the new diaspora. New diaspora means people who have migrated in the last 2-3 decades. What about people who migrated in 1890s, who were taken as indentured laborers? Unka interaction with Indians or Indian government is very less. Then initiatives like Pravasi Bharatiya Divas, good initiatives, fine, but do you not clearly notice that in this Pravasi Bharatiya Divas, how many laborers who are working in Qatar, how many laborers who are working in UAE, they are also Pravasi Bharatiya, participate, their work is recognized. Generally the well-off people at very high positions, they would be invited, उनके साथ interaction होगा, उनके issues को raise किया जाएगा. Vulnerable groups are ignored. Then there is a problem of splintered nationalism. Some of them are citizens of other countries. वो उनके armed forces में भी serve करेंगे. What happens in that scenario? Then there are some other concerns related to Indian diaspora. One is the Gulf region में human rights violation is a concern. Issue of non-payment of salaries and illegal confiscation of passports by employer is a common thing in Gulf region. Possibility of large-scale return from Gulf is there. COVID-19 के time हुआ, but it is said that in fact we would study it यहाँ पे West Asia specific issues में. There are a number of reasons because of which a lot of Indian workers who are working in West Asia may face issues. One is, right now a lot of them are working in the oil industry. But with climate change ka pressure, 5-10 years down the line, it may happen that those industries may not be employing a lot of people as world moves towards renewable energy. But there are other aspects also. West Asia is a very turbulent region. Wars and all these things keep happening. Shia-Sunni conflict is there. Then Israel-Arab conflict is there. Sometimes it may escalate and situation may worsen. Then there are other systems like Kapala labor system. It's very exploitative. What is this Kapala labor system? Here, when workers are taken, like when workers from India go to these West Asian countries, there's a sponsorer. That sponsorer is responsible for their accommodation. Their sponsor is responsible for their travel and all. But this sponsor or this Kapala system comes under Ministry of External Affairs and not under Labor Ministry. So, जो वहाँ के labor laws है, they are not applicable on Indian workers. So they are not protected by those labor laws. They face issues there. Their visa, their passport and all is taken by them. कोई उनका sponsor है, so it's difficult for them to do some other job. So it reduces opportunities for them. It increases exploitation for them. Then recently, Nitakat law has been brought in Saudi Arabia. In this, what they're trying to do, they're trying to replace foreign workers with domestic workers. These are some of the concerns of Indians in West Asia. तो कई बार ना ऐसे रीजन स्पेसिफिक क्वेश्चंस आते हैं. इंडियन डायस्पोरा इन सेंट्रल एशिया, और इंडियन डायस्पोरा इन ईस्ट एशिया, Indian diaspora in West Asia. So other than knowing the broader issues, you should also know the region specific issues. If you go to Western countries like US, Canada, UK, France, you would see that there is increasing protectionism in these countries, which is becoming a cause of concern. Racism still persists in these countries. After Brexit, the visa norms in UK have become very rigid. Dual citizenship is another aspect which the diaspora in India have been demanding. What is this dual citizenship? UK, US, these countries allow dual citizenship, that a person can be citizen of two countries. So एक UK का बंदा goes to USA and becomes citizen in USA, but that person can also remain a citizen of UK. This is the idea of dual citizenship. Indian constitution does not allow for dual citizenship. If you acquire citizenship of some other country, you lose your Indian citizenship. But there has been some demand from the diaspora that we should also be able to benefit from the idea of dual citizenship. Okay, so what should be done to deal with these problems, these issues? What are the key things that we can keep in mind? First, we are saying that way forward mein, you have to come up with a policy. What are the principles that you will follow? Well documented policy should be there so that you know what has to be done in different scenarios. You will not be interfered with, you will not be questioned. Second, we need to create an authentic database. Here, we are saying that Indian mission abroad should play a more proactive role in developing closer contact with the community. Diaspora community should be registered with the embassy. This database can be useful for preparing effective welfare schemes for overseas Indians. It's not only for ensuring welfare schemes for Indian diaspora, but also to ensure that they are not suffering, they are not facing issues. Then we need to increase research and development in the field of for our diaspora. So we are saying that we need to create research institution for diaspora research. This will help in carrying out disaggregated studies in order to fully understand the problems and potential of diaspora. And here they may play an important role in setting up database effectively. We are also saying prioritize focus on recent returnees. COVID-19 की वजह से जिनको आना पड़ा या फिर war की वजह से जिनको आना पड़ा. Interact with the host countries to understand the problem. Why are Indian students not able to go back to China? China mein things have opened up, colleges have opened up. What would happen to students who have come back from Ukraine? We have to ensure, these are short-term issues, but we have to prioritize them as well. Comprehensive rehabilitation schemes should also be developed. There are situations, there are chances that a lot of our workers who are working in Middle East, West Asia, they may have to come back. Now, not every person from Indian diaspora can become Dhirubhai Ambani. Dhirubhai Ambani was also once part of Indian diaspora, was working somewhere else. So you cannot expect कि सब आके business ही करेंगे. You'll have to rehabilitate them. You'll have to provide opportunities for them. You'll have to ensure that they are not facing a lot of issues. Review initiatives like Pravasi Bharatiya Divas to make them more inclusive. Just focusing on the elite section of the Indian diaspora will not solve problems of Indian diaspora, will not bring grievances, real grievances of Indian diaspora. Correcting bias towards new diaspora. Only पिछले 2-3-4 decades में जो लोग गए हैं वो खाली वो important नहीं है. It's morally important for us that we are connecting with Indian diaspora जो वेस्ट इंडीज वाले रीजन में रह रहे हैं, मॉरिशस में रह रहे हैं, जो एज स्लेव्स नहीं एज इंडेंचर्ड लेबर्स गए थे इंडिया से. दे शुड ऑल्सो, उनके साथ भी आर इंटरेक्शन नीड्स टू गो अप बिकॉज देयर कॉन्ट्रीब्यूशन, दे मे ऑल्सो फील कनेक्टेड विथ इंडिया. व्हेन नेम्स लाइक राम नरेश is used, it clearly shows that they are people of Indian origin and they would feel connected with India. They would work more for the benefit of India if India is reaching out to them more effectively. So old diaspora also needs to be interacted with. Then center or state के बीच में there should be clear division of labor. Sometimes, especially in difficult times, it happens, it is responsibility of state government, it is responsibility of central government, those kind of things. Policy perhaps would be able to clear this aspect as well. And then protect the rights of worker abroad. ये तो people जो वेस्ट एशियन कंट्रीज में रह रहे हैं, जो मिडिल यूएस में रह रहे हैं, उनके राइट्स प्रोटेक्ट करना भी इम्पोर्टेंट है. राइट टू लिव, राइट टू वर्क विथ डिग्निटी, to ensure that the system by which they are going is not exploitative. These are different areas that we need to work upon. Indian diaspora is significant, but Indian diaspora may also be vulnerable. We have to take advantage of their significance, but we have to ensure that they do not remain vulnerable. With this kind of diaspora policy, we'll be able to function, we'll be able to take full benefit for India of Indian diaspora. Fine. इंडियन डायस्पोरा वाला टॉपिक इतना ही होता है. अब देखो, इसके अलावा अब इंडियन डायस्पोरा में आपको क्या पढ़ना होगा. आपके इंटरनेशनल रिलेशन में एक पूरा पॉइंट है इंडियन डायस्पोरा का. इसके अलावा क्या पढ़ना होगा अब से आपके एग्जाम तक, इंडियन डायस्पोरा रिलेटेड इश्यूज जो इमर्ज हो रहे हैं ना, वो इसमें ऐड करते रहेंगे. या जो इनिशिएटिव्स हम ला रहे हैं वो इसमें ऐड करते रहेंगे. अब जब हम इंटरनेशनल रिलेशंस पढ़ेंगे, उसमें जब इंडियन डायस्पोरा वाला सेक्शन आएगा, आई एम नॉट गोइंग टू कवर इट. दिस इज व्हाट यू हैव टू स्टडी फॉर Indian diaspora. Fine. Now, अरे we are saying educational institution बना दो, जो इंडियन डायस्पोरा, जैसे डिफेंस पे फोकस रिसर्च इंस्टीट्यूशंस बन रहे हैं ना, वैसे. ये क्या सब बच्चे अपनी मर्जी से ब्रेक ले रहे हैं? चलिए, लेट्स गो टू नेक्स्ट टॉपिक. क्या आज कितना टाइम हो गया? 2:30 हो गया. आज यहीं रुके, है ना. मैं आपको नेक्स्ट वीक के लिए प्लान देता हूँ. विल नाउ हम 2-2 एक्स्ट्रा क्लास लेना शुरू करेंगे. अरे इतनी छुट्टी हो गई आपकी. देखो, मैं आपको बता देता हूँ, हम 2-2 एक्स्ट्रा क्लास लेना शुरू करेंगे जहाँ पे टारगेट मेंस पढ़ना है हमें. वीकली क्लासेस वुड गो एज इट इज. इन केस मंडे टू फ्राइडे में एक्स्ट्रा क्लास नहीं ले पा रहा हूँ, मैं अभी अनाउंस कर रहा हूँ, नेक्स्ट सैटरडे संडे योर क्लासेस वुड बी फ्रॉम 2 PM to 8 PM. तो 2 PM to 8 PM, जिसमें वी विल बी डीलिंग विद टारगेट मेंस इन 2 to 5 PM and the weekly current affairs in 5 to 8 PM. The weekly current affairs would be from 5 PM to 8 PM on Saturday, Sunday. Other than that, we'll have some extra classes for target main section also. ठीक है, I'll see you. I'll give you the timetable for extra class timetable for next week. बाकी Saturday, Sunday 5 to 8 PM we'll be meeting with weekly current affairs thing. Okay, thank you very much.